All right, this video is going to be pretty short because I've also attached a lot of YouTube videos for how to do constructions. The best way to do that is to watch somebody do that, and there's already a lot of excellent YouTube videos made, and so I have just attached those. If you're teaching these constructions in a class, I would have one of those videos showing as you're walking around helping your students. That's the absolute best way to teach these constructions. A lot of your students are not going to be familiar with how to use the compass, and so that's something that they're going to have to learn. And absolute best way to do it is to show a video up on the board. There are big ones that you can use on a whiteboard that you can get and show it on the board as well. But what I've had most success with is showing the video on the board and walking around and helping and just showing it again and again and again and again until all the students are able to do it. And so as you get to the part of your notes where you're doing those constructions, you're going to need to go and use one of those YouTube videos to help you. There's two types of compasses. There's the safety compass and then there's the standard compass, and I've attached the videos for both. And so just look for those. This is a section where you're absolutely going to need to read your book because there's definitions in the book that I want you to get from the book, not from the notes for this section. And you're absolutely going to need to watch the YouTube videos. So it's not a long reading in the book. Please take the time to read that. I don't think we utilize the book as much as we need to. And so definitely do so there. And so we'll go ahead and get started. This section focuses a lot on proving things congruent, copying an angle congruent to the other angle, constructing a perpendicular bisector, and then by the time we get to 12.4, we're going to go into similarity. So those are the first definitions I want to go over. Similar, I want you to go ahead and write in this symbol. Here is the symbol for similar, and I'm actually going to write it over here where I can do it bigger. That right there is the symbol for similar. Similar means they're the same shape, but not necessarily the same size. And so let me do the best I can to draw that for you. I have one triangle. I have another triangle that's the same shape, but it's not the same size. What makes objects the same shape is the same angle measurement. And so when the angles are the same measurement, we get a shape that's the same, but it doesn't mean they're congruent. Congruent means they're the same shape and the same size, as you can see right here in the picture below where you see triangle congruence. All the angles and all of the sides are the same. And so there's a few statements that I want you to write, and it says here, write an appropriate symbolics congruent for the pair of triangles. I'm going to do it over to the side. You can do it below this line here, but I want to be able to show you this. The way that you would write this is you would write triangle ABC is congruent to triangle, and if I'm going ABC, what is congruent to A is D, B and E are congruent, and C and F are congruent. So I have to write it in the same order. It's congruent to D, E, F. So that's the congruency statement. Other things that you could write is that angle A is congruent to angle D. Angle B is congruent, to angle E. And angle C is congruent to angle F. You could also write that what segments are congruent. So you could say segment AB is congruent, and since you're going A to B, you have to go from D to E. So AB is congruent to DE. Segment BC is congruent to segment EF. And then finally, segment AC is congruent to segment DF. And so those are all of the congruency statements that I could write if I know that the triangles are congruent. CPCTC is something that overwhelms students. That stands for corresponding parts of congruent triangles are congruent. If you know the triangles are congruent, then their corresponding parts are congruent. And by corresponding, I mean A corresponds to D, B corresponds to E, C corresponds to F. And so if you are told that the triangles are congruent, then you can write all of the corresponding pieces of that are congruent. Now what we have is we have some theorems to go along with that. And those theorems actually save us a lot of work. Mathematicians have figured out, number one, if all three sides of the triangles are congruent, then you can prove that the two triangles are congruent. You don't have to know anything about the angles. There's actually 6 parts, 6 corresponding parts, the 3 sides and the 3 angles. If you know the 3 sides are congruent by that theorem, you can assume that the 3 angles are congruent and prove that the 2 triangles are congruent without having any markings on the angles. And I'm giving you page numbers to go look that up in your book. Side, angle, side. If you have 2 sides, 2 corresponding sides, and the included angle, that's big. That's something that a lot of people miss. It's the angle between those 2 sides. If those are congruent, then you can prove the triangles are congruent without having to know the other corresponding pieces. Another one is hypotenuse leg. And so this only works on right triangles. So the first 2 work on any triangles. The last one, if you have 2 triangles that you're trying to prove are congruent, if you know that the corresponding leg is congruent and the hypotenuses are congruent, then you can prove that the 2 triangles are congruent. And so let's go ahead and work example 1, and then I'm also going to pull up for you another little worksheet to show you a few more examples before we actually start doing some constructions. And so number 1, I'm actually going to go to a separate sheet of paper, and so that you can see this a little bit better, you can just draw it right here on your notes. So 1A, what we're trying to prove, and I'm just going to draw a sketch. A sketch is just to help you. It doesn't have to be perfect. I'm looking at triangle EFG, and then J goes with E, K goes with F, and L goes with G. And I'm given 3 pieces of information. I'm given that segment EF is congruent to JK. I'm giving that segment FG is congruent to KL. I'm given that angle F is congruent to angle K. So I look at what I'm given and I decide, do I have enough information to prove that these 2 triangles are congruent? Because here's the reality. I know nothing about these sides. I know nothing about these angles. I just have the 3 pieces of information they give me. If those informations fall under side, 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 angle, side, or hypotenuse leg, then I have enough information to prove that the 2 triangles are congruent. What I have here is sides are congruent, angle is congruent, sides are congruent, the angle is between the 2 sides, it's included. So here's how you're going to answer this. I can prove that triangle EFG is congruent to triangle JKL by the side, angle, side property. And so that's how you're going to do part A. All right, let's get a fresh page to do part B. So it's going to be the same sketch pretty much. Just do the best you can to draw 2 triangles that we're trying to see if are congruent. EFG, JKL. Okay, what I'm given is that EF is congruent to JK. EG is congruent to JL. Angle F is congruent to angle K. Now once again, I don't know anything about these sides or these angles. Everything that I've circled in green, I don't know anything about. But if I have 3 pieces of information that fall into side, 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 angle, side, or hypotenuse leg, I can prove that the 2 triangles are congruent and all 6 corresponding pieces are congruent. So let's see what I have here. I have a side pair that's congruent, a side pair that's congruent, and an angle that is congruent. Now when you read these, your angle has to be between or included between the two sides. What I have is a side, then an angle, or an angle, then a side, then a side. That's not one of the theorems. Now you're going to read this, you know, clockwise or counterclockwise. I have this, then I have this, then I have this. Or you could say I have this, then I have this, then I have this. But you're going to go in order. And what I have is either side, side, angle, or angle, side, side. That's not one of those three theorems. So what your answer here is that you cannot prove that these two triangles are congruent. They could be, but you can't prove it based off of one of those properties. And your students are not going to forget this, especially at the age level we learn it. They're going to see that right there, and they're going to remember that that does not work. Okay, what I want to show you is this is a foldable that I have that I usually like to hand out. You can just see one little part of it here. Let me see if I can move this over a bit so you can see the whole thing. So this is what the front side would be, and then when you open it up inside, it folds open to this right here, and I'll kind of scan it back and forth. But I like this foldable because you can cut it, and it has all of these definitions here, because we're learning 3 of these today: side, 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 angle, side, hypotenuse, leg. In the next lesson, we're going to add angle, side, angle, and angle, angle, side, but that's in actually 12 too. So I like this because it gives these definitions, and then it also gives some practice problems. There's other variations of this, so you could give it to your students without the definitions here in it, where they have to actually write those postulates or theorems or properties, and then go over and do the practice. But what I wanted to do is I just wanted to maybe do a few more practice on these and just see what we have. So just kind of watch as I go through these. We're not going to do all of them today because we haven't learned those last 2 properties. But on the first one, I'm going to see if I have enough information to prove that these 2 triangles are congruent based off of side, 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 angle, side, or angle, side, angle, or hypotenuse, leg. Actually, we're just going to do the theory that we've learned so far. On number 1, what students have to understand is that these 2 triangles share that side. Since they share that side, then you could say that BD and DB are congruent because it's the same side. So when I look at this, I have sides that are congruent, I have angles that are congruent, and I have another side that's congruent. So you can say triangle AB, what is that last letter? D, ABD is congruent to triangle. Okay, what went with A? That's C. What went with B on the other one? That's DB. So you have to write those corresponding pieces. You can prove that those 2 triangles are congruent by side, angle, side. All right, I want to look at number 5 because we haven't had that yet. When we look at this, you can see none of the angles are marked. So the only way that we could prove these are congruent is by side, side, side. And when I look at this one, I can see that all 3 sides of one triangle is marked congruent to all 3 sides of the other triangle. And so I can say triangle CAE is congruent to triangle FBD by side, side, side. And so we haven't had one of those yet, so I wanted to show you that one. Another one that we haven't seen yet, let me go down because I want to show you this. We haven't seen an example of hypotenuse leg. Hypotenuse leg only works on right triangles. I can tell you when you look at number 3, some students are going to think hypotenuse leg because they see the right triangles. But on these 2 right triangles, the hypotenuses right here are not marked, and so you could not use hypotenuse leg. Now when you get up to down to number 7, you see right triangles, and you can see that this leg is marked congruent to this leg, and this hypotenuse is marked congruent to this hypotenuse. Remember, the hypotenuse is across from the right angle, and you can see more pictures of that in your textbook. But when you look at that, these 2 could be proved congruent by hypotenuse leg. And so you could write that congruency statement. We'll come back to this little foldable a bit more in the next section after we've gone over the rest of those properties. All right, and that just shows you if you bought that as the teacher, it would give you the answer key and then how that could be cut and folded and put into an interactive notebook if you chose to do so. All right, the next part here is constructing congruent angles, and you can use the side, side, side property by making any part of an isosceles triangle. You'll see that really well if you look at that in your textbook. So what I want you to do is I want you to construct an angle congruent to the angle in part A and congruent to the angle in part B. And the instructions are in page 497, but I've also attached 2 very good videos that are going to show you how to do that. So you can pause this video and take the time to do that. After you've done that, I want you to come back and make sure you understand these theorems about isosceles triangles. On isosceles triangles, the angles opposite the congruent sides are congruent, the base angles, and the angle bisector of an angle formed by the 2 congruent sides is a perpendicular bisector of the third triangle. And so what I'm going to do is that picture of that is on the next sheet. I'm going to go to that and explain those 2 pieces of information to you. So if you have this, this theorem says for every isosceles triangle, the angle opposite the congruent sides. So right here, these sides are congruent. These angles are opposite, so that's opposite that, that's opposite that. If the 2 sides are congruent, then the base angles opposite those sides are also congruent. That's number 1. Number 2, the angle bisector formed by the 2 congruent sides. So this is the angle formed by the 2 congruent sides. If you bisect that, meaning cut that in half, it's going to create a line that's a perpendicular bisector of the third side. And so let me kind of clean this up so we don't have so much going on here. So angle R is the angle formed by the 2 congruent sides. If we bisect that, cut that angle in half, it's going to create a perpendicular bisector, meaning it's going to split this right in half. And so both sides of that perpendicular bisector are going to be the same. That's going to be the next construction that you do. I'm going to give you a line, and I'm going to ask you to create the perpendicular bisector. I have attached 2 very good videos, YouTube videos that are going to go through that in depth with you. And so you can either choose to use the safety compass or the standard compass, and it'll show you how to do that. And then the last thing that I'm going to do is I'm also going to attach some extra practice. Like I said, this is one section where I really need you to read your textbook. I really need you to watch the YouTube videos. And then I'm even going to attach some extra construction practice that's completely optional for you. But just make sure you're aware of how these compasses work and how these constructions work. And just please on this section, take the time to read the textbook and watch the YouTube videos.